welcome to the video lecture series of Grade 10 Chemistry. Today we will discuss about the types of chemical reactions. What are the different types of chemical reactions? There are four types of chemical reactions commonly. They are combination or synthesis reactions, decomposition reactions, single replacement or single displacement reactions, and double displacement reactions. So let us discuss one by one in detail. The first one is combination reactions. What are combination reactions? In a combination reaction, two substances combine to form a new substance. For example, if A is reacting with B, the product will be AB, which means two substances A and B combines together and form AB. This is called a combination reaction. So let us study the different examples of combination reaction. The first one is burning of magnesium ribbon. Magnesium ribbon, when burns in air, it produces a dazzling white flame, and after burning, an ash color substance will be obtained. So this product is magnesium oxide. So the reaction will be magnesium, the symbol of Mg. Magnesium is Mg. Mg will be combining with O2, oxygen, and form magnesium oxide. It is a solid substance and it is ash in color. So this is an example of combination reaction. Now another example we can study, that is actually the formation of calcium oxide. Calcium oxide is commonly known as quicklime. When it reacts vigorously with water, it produces slaked lime. So when you look at this picture, you can understand that calcium oxide, when you put in water and when you touch the sides of the beaker with your hand, you can feel a sense of heat, which means this reaction between calcium oxide and water releasing a large amount of heat. So this is an example of exothermic reaction as well as combination reaction. So the equation will be calcium oxide, quicklime, is reacting with H2O and it produces slaked lime. And this reaction producing large amount of heat, which means this is an example of exothermic reaction. Another simple example of combination reaction is burning of coal. So carbon burn in air to form carbon dioxide. Also, formation of water is an example of combination reaction. So what are the reactants here? Hydrogen and oxygen. It will be combining together and form water. Now let us study about decomposition reactions. So when you look at this diagram, you can see that a substance, it is made up of two components A and B, and on decomposition, which means this compound A and B will be breaking down and form two separate components A and B. So this type of reactions we say decomposition reaction. So what is the decomposition reaction? Decomposition reaction means a single reactant breaks down to give similar product. So for example, calcium carbonate, heating of calcium carbonate. On decomposition, calcium carbonate will produce calcium oxide and carbon dioxide. But decomposition reactions will not occur naturally. It needs some kind of energy for the decomposition. So what type of energy it is needed? It can be thermal energy or electrical energy or light. So accordingly, we'll be classifying decomposition reaction into three types: thermal decomposition, electrolytic decomposition, and photolytic decomposition. Thermal decomposition means the decomposition or breaking down of a compound by giving heat. Electrolytic decomposition, as the name indicates, the compound will be decomposing by using electricity. In photolytic decomposition, the decomposition is done by light. So these are the three types of decomposition reactions. Now let us look in detail about thermal decomposition reaction. So as the name indicates, thermal means heat. So this type of decomposition we need heat. So these are the main examples: decomposition of ferrous sulfate, decomposition of calcium carbonate, and decomposition of lead nitrate. If we study the thermal decomposition of ferrous sulfate, okay, ferrous sulfate, the formula is FeSO4, which is green in color. On heating, it is decomposed and form ferric oxide. Its formula is Fe2O3, okay, and the two other products are SO2 and SO3, sulfur dioxide and sulfur trioxide. So this is the heating reaction of ferrous sulfate. So in the beginning of the reaction, the ferrous sulfate color is green, but after the decomposition, ferrous sulfate is converted to ferric oxide. Its color will be changing to brown, and we can feel a kind of smell in which sulfur is burnt. So sulfur dioxide and sulfur trioxide is produced. So these two gases will produce a smell of burning sulfur. So what are the characteristic changes when the ferrous sulfate is heated? The green color will be changing into brown color. At the same time, you can feel a smell of burning sulfur. So this is a clear example of thermal decomposition. Now, another example of thermal decomposition is calcium carbonate, heating of calcium carbonate. So what is the formula of calcium carbonate? It is CaCO3. Calcium carbonate is generally known as limestone, which is a solid substance and it's white in color. When you heat calcium carbonate, it decomposes to give calcium oxide and carbon dioxide. And calcium oxide is a solid substance and carbon dioxide is a gaseous substance. And how do we identify carbon dioxide gas? This carbon dioxide gas can be identified by passing it through lime water. Lime water is Slackert lime solution. So when you pass carbon dioxide through lime water, it turns milky. So this is the identification test for carbon dioxide. So heating of calcium carbonate is a very good example of thermal decomposition. Now, the third example for thermal decomposition is lead nitrate. Heating of lead nitrate. What is the formula of lead nitrate? PbNO3 twice. It is on heating, it decomposes to give lead oxide. Formula is PbO, which is red in color, and nitrogen dioxide, and it produces brown fumes, and also it gives oxygen gas. So lead nitrate on heating, three products are formed: lead oxide, nitrogen dioxide, and oxygen gas. Lead nitrate is a colorless substance, but after the reaction you can see some red color residue at the end of the test tube, that is lead oxide. And it also produces brown colored gas, that is nitrogen dioxide. So this is also an example of thermal decomposition. Now we are going to discuss about electrolytic decomposition. As the name indicates, it is the decomposition of a substance by electricity. So when you pass electricity through a substance, it decomposes and it will produce its component elements. For example, if you are doing the electrolysis of water, the water will give you its component elements, that is oxygen and hydrogen. So in this picture you can see the electrolysis of water. Okay, there are two test tubes have taken. One is acting as anode and the second one is cathode. Okay, so the anode is a graphite rod and even cathode is also a graphite rod. Both are connected to a 6-volt battery and the electrodes are connected to a test tube. So the test tube here actually taken to collect the gases after the electrolytic reaction. Okay, so when you pass electricity through this water, okay, it decomposes to give hydrogen and oxygen. But in this water, we need to add a little bit acid or alkali because pure water is not conducting electricity. So the reaction will become faster if you add any type of acid or base. But mostly we are adding sulfuric acid. So the water formula is H2O. On electrolytic decomposition, it will produce oxygen gas on the anode and hydrogen gas will produce in the cathode. So when you look at this test tube, you can see that hydrogen gas is collected more in amount when compared to the oxygen gas. What might be the reason for this? In water, when you look at this water formula, you can see hydrogen formula is H2 and oxygen is O, which means hydrogen is twice than oxygen. So the hydrogen and oxygen ratio will be 2:1. That's why the hydrogen gas collected in cathode will be twice the amount of oxygen gas. This is an example of electrolysis of water, which means it's an electrolytic decomposition. Now, the third type of decomposition is photolytic decomposition. Photo means light. If you are keeping silver chloride, which is white in color, okay, it undergoes decomposition. It breaks down and form silver and chlorine. So white color silver chloride will be breaking down and will get the product silver, which is gray in color. And the gas produced is chlorine, which is greenish yellow in color. Okay, so this is an example of photolytic decomposition. Similarly, if you keep silver bromide in place of silver chloride in sunlight, okay, it decomposes to give Ag and bromine. So these reactions are mainly used in black and white photography. So how do we store the silver chloride and silver bromide? Usually in the lab, these two substances are stored in brown colored bottle or colored bottles. What may be the reason for that? Can you tell me? Usually any type of decomposition reaction, it requires energy in the form of heat, light or electricity for breaking down the reactants. Okay, so energy is absorbed in these kind of reactions. So we say decomposition reactions are endothermic reactions. Now let us study about displacement reactions. What is meant by displacement reaction? Displacement reaction means a more reactive element can displace a less reactive element from its compound, which means that we have a compound A and it is reacting with the compound BC. Okay, and when we compare A with B, and if A is more reactive than this compound B, so A can displace B from its compound. So which means A will displace B and A will occupy the position of B. So the reaction will be A plus BC will give AC plus B. So this is the displacement reaction. So a more active element can displace a less active element from the compound. So B is less reactive. That's why A can displace. A can push out B from its compound. Now, what are the two types of displacement reactions? Single displacement and double displacement. What is meant by single displacement reaction? So the reaction which we explain now is a single displacement reaction. Like as I told before, a more reactive element can displace a less active element from its compound. For example, if we consider the reaction between zinc and copper sulfate, and when you compare the zinc metal with the copper metal here, zinc is more reactive than copper, which means that zinc can displace copper from its compound. So copper will be coming out, okay. Then the remaining product will be zinc and SO4, which means it is zinc SO4, ZnSO4, that is zinc sulfate. So Zn plus CuSO4 will give you Cu plus ZnSO4. This is an example of single displacement reaction. Now, these are two other examples of single displacement reactions. Fe plus CuSO4, iron plus copper sulfate, okay? So you need to compare copper and iron here, and iron is more reactive than copper, so that iron will displace copper from its compound. So the overall product will be FeSO4 plus Cu. Copper sulfate is actually blue in color, so after the reaction you will get a product of FeSO4, that is iron sulfate or ferrous sulfate, which is green in color. Then another reaction is a reaction between lead and copper chloride. Okay, so lead is more reactive than copper, so lead can displace copper from copper chloride. So the product will be PbCl2, that is lead chloride and copper. These are the two other reactions of single displacement reaction. Now, what is meant by double displacement reaction? So these are the reactions in which there is an exchange of ions between the reactants. Okay, so what is meant by an ion? So just consider sodium sulfate. Okay, here Na is there, also SO4 is there. Then what is the second reactant? That is barium chloride. So sodium will be exchanging its SO4 with the chlorine. So you will get BaSO4. And the barium, its ion is chlorine. So this chlorine ion will be exchanging with the SO4. So product will be NaCl and BaSO4. Okay. So displacement reaction means there will be an exchange of ions between each element. So Na2SO4, Na will be exchanging its SO4 with the chlorine, and in BaCl2, chlorine's ion will be exchanging with the sulfate ion. So NaCl and BaSO4, barium chloride, are the final products. So these type of reactions are called double displacement reactions. And here actually, when you conduct this reaction in a lab, we can see that at the end of the reaction, a precipitate will be obtained. Precipitate means a solid residue will be obtained at the end of the reaction. So barium sulfate is the white color solid residue, a solid substance obtained in the reaction test tube. So this barium sulfate we say precipitate, which means a white color solid residue. So these kind of reactions are generally called precipitation reactions. Thank you, children. We will discuss in the next video about oxidation and reduction reaction.